I'm speaking to you on behalf of the Aberystwyth University part of the CHERISH Project team. And our principal objective as part of the CHERISH Project is to investigate the record of environmental change, climatic variability across our study areas in Ireland and Wales. We're using a range of evidence from lake sediment cores, coastal wetlands, drilling cores through sand dune systems, and also through intertidal areas, to develop a record of climate change, evidence for past extreme events, and also identify the broader coastal landscape evolution across our site. It's important for us to have a robust chronological framework, and we're using a combination of radiocarbon dating and optically stimulated luminescence dating, which is particularly useful for dating sand deposits, and the mobilization of sand might give us an indication of episodes of past storminess and substantial coastal change. And so collectively, these records are being integrated with the archaeological, historical and monitoring data that's being collected around the heritage sites as part of the CHERISH project, to provide this broader context and understanding of the environmental and climatic change, and linking that to the challenges that we're facing today as the climate warms. I haven't got time to talk about all of our areas today, but we're working around the Welsh coast and also in Ireland. But today I'm going to focus on some evidence from the southwest coast of Anglesey in North Wales, and down through just to the south of Carnarvon to Dinas Dinllé, one of our key CHERISH sites here. And this is a really interesting landscape, rich in archaeological evidence, but also has clear evidence of major landscape change over the relatively recent past, with extensive sand dunes at Newborough Warren and Aberystwyth. And previous evidence has indicated that these dune systems have been active during the medieval period, which ties in with historical records of great storms and sand inundation during the 1300s. But there's also been more recent phases of activity around 200 to 300 years ago, and that's evidence from previous work using luminescence dating. I'm just going to take you first of all to a site called Rhyddgaer on the brine estuary on the Menai Strait in that southern tip of Anglesey. And this is a site that's been investigated by colleagues at Bangor University and Gwynedd Archaeological Trust, led by Nancy Edwards and Dave Hopewell. And this is a rare example of an early medieval farm settlement, which has subsequently been buried in sand. And we were able to go back with Gwynedd Archaeological Trust, who excavated two trenches down to this well-preserved ridge and furrow medieval plough surface. And one of the interesting questions here is, how quickly was the sand deposited on top of this sand? How old is it? How long did this deposit take to form? So my colleague Helen Roberts has been working on the luminescence dating here, and samples from two trenches indicate that the sand was deposited probably over a period of about 100 years, between 1120 and 1220 AD. Those luminescence dates are consistent across the two trenches that were dug. A later date suggests that deposition may have continued until around 1440 AD. But interestingly, this major phase of sand accumulation occurred prior to this sort of narrative of the 1300s being the major phase of medieval sand inundation in this area. The soil here is aged between 600 BC and 990 AD, indicating Iron Age and medieval activity at the site. If we move a little further up the coast to Llyn Coron, and this is a dune impounded lake. It's here behind the dune system at Aberystwyth, and was formed by the blockage of a river by these dunes that were encroaching inland. And this is where the earlier evidence from luminescence dating indicated this phase of activity around 700 years ago, around 500 and around 300 years ago. But we're interested to see whether the lake can provide a longer term history of this site. So we retrieved a sediment core 2.4 meters long, and in this picture of the core from the field, we identified very quickly two distinct sand layers that were present in the core. And we the base of the core, we reached gravel, so we're confident that we actually reached the earlier stages of the formation of the lake. If we put this into put this stratigraphic information together with some geochemistry and some magnetic susceptibility, we've actually got multiple layers of sand, the earliest being 1160 BC, and just after the earliest formation of the lake. So this is the sort of earliest encroachment of sand to the site. And then we've got these two thick deposits, which are the ones shown in the photograph. And these are revealed to be 160 BC age and an early medieval age of 540 AD approximately. The geochemistry, which picks out these sand layers through the titanium and the silica records, also revealed a further layer of sand in the upper part of the core, which we can see there at about 0.6 meters depth. And that's bracketed by radiocarbon dates between 990 AD and 1110 AD. So what we've got here is stratigraphically consistent, coherent record with a chronology with two independent means. We've got 4 clear phases of sand mobilization and deposition in the area, suggesting episodes of increased, potentially increased storminess over these time period episodes of storminess. So we've been able to extend the existing information about sand deposition in this area over a much longer time period through the late Holocene. And this later phase of deposition links very nicely to the evidence from Rhyddgaia. A little further up the coast, we have Llyn Maelog at Rosnega, and this coastal lake here, which has dunes, sand dunes in front of it. We were expecting to find a similar record to that which we recovered from Llyn Coron. It's very similar kind of setting. We retrieved a 4.5 meter core from this site, and actually it covers a much longer time span. We've got a full Holocene record here going back to the post-glacial clays. We've got evidence in the lower part of the core of the Mesolithic landscape, a more terrestrial signal there with sort of peats and soil formation and woody fragments. But above that lies a distinctive section of grey clay, which in the field, in a gap in the core, we've got a shell imprint here. So it was clear that we were likely looking at marine sediments in what is today a freshwater lake. Our local contacts in the community alerted us very recently to exposures of peat and wood on the foreshore at Traethlydan, which is the beach in front of the lake here. So we've got an opportunity here to connect the stratigraphy from the core with what is exposed on the foreshore, and those dates are we're getting ready to send these dates off for processing as we speak. If we look a little bit more detail at the stratigraphy of Llyn Maelog in its earlier stages, around 12,000 years ago, the diatom evidence indicates a freshwater, shallow, relatively freshwater, shallow lake. As that infilled and became more terrestrial, we see the deposition of soil and the kinds of vegetation we've got. We've got some birch, hazel, and willow. And as the site became waterlogged, we see more alder coming in as we might expect. But then we see a very big change in the diatom flora. There's no diatoms preserved during the soil but then we've got this very distinctive change in the diatom flora, which confirms that this is a marine incursion, and that's bracketed between 7,500 and just after 7,000 years ago. And above that, we see a return to freshwater diatoms and the formation of the freshwater lake that we see today, and that's persisted right the way through the last 7,000 years. We don't see evidence of distinctive visible sand layers in the same way that we do at Llyn Coron. So again, sort of a rather different stratigraphy and context to environmental change provided by this site. Now, what's interesting here is that this marine incursion between 7,500 and 7,000 years ago, is this part of a record of ongoing and more gradual sea level rise, as indicated by other empirical evidence from the area suggested by research by Mike Roberts and the Menai Strait, and also supported by more recent information from work at Mathtraeth and Roscollin. But modelling by the British Chrono Group, more recent modelling suggests that there is potentially a high stand here in this part of Anglesey around this time, but it is fine margins, and we need to be able to confirm this by doing some further analysis. So the jury's still out on whether this represents a high stand or part of that gradual relative sea level rise that we see. But of course, the nature of sea level change has implications for the archaeology, and there's the sort of extensive Mesolithic landscape here that is identified by this 30-metre contour here. And so understanding the nature of sea level change over long timescales is important for the archaeology, but also provides some context for the challenges of future sea level rise in this very low-lying area. And just to sort of add some final context to our other sites, if we go a little bit further south to the Iron Age hill fort of Dinas Dynlley, which was excavated by the Gwynedd Archaeological Trust on behalf of the CHERISH Project in summer 2019, where these really well preserved walls were uncovered. They've been buried beneath thick sand deposits, the walls of this roundhouse. And my colleague Helen Roberts here is taking some luminescence samples through the stratigraphy to identify whether this sand was deposited, whether it was deposited rapidly, whether it's accumulated over centuries, and also the timing of that deposition. Is it related in any way to potentially to the abandonment of the site, or is this something that occurred afterwards? So the dates are in progress at the moment, and we're interested to see how the timing of the sand deposition here links to our evidence from Llyn Coron and also from Rhydd Gaer. We also have evidence from submerged peats, which are exposed at low tide at Dinas Dynlley. There's some remnants here, and these are again dated to around 7,500 years ago, which link into that the onset of the marine incursion at Llyn Maelog. And this is also supported by data that we've also recently collected from Aberystwyth on the Llyn Peninsula, where again we have extensive evidence of the submerged peats. There are two main exposures. The lowest one is only exposed at the very lowest tides, and we were able to sample these late last year. And the date on the wood here, and we've also got some of the dates on plant macrofossils, again between 7,500 and 7,000 years ago. So these dates are consistent with other dated peat remains around the Llyn Peninsula at Porthnagle and also on the North Wales coast. So we seem to have a very consistent picture emerging here in North Wales. And what we're keen to do now is to link that to our other sites around South West Wales and also across in Ireland to see how consistent this these key phases of environmental change, the sea level, the periods of storminess, how consistent are they across our study areas? So We are providing new information on Holocene sea level change. We are developing this coherent regional picture of the timing of late Holocene sand movement and deposition, and we're integrating these records across the wider CHERISH study areas, and that's what we'll be focusing on for the next part of the project. So finally, I'd just like to say thank you to all our stakeholders and our collaborators and to the landowners who provided access to the site, but also to the local communities who have shown us a huge amount of support with the work that we're doing, and we're keen to share our results with them and discuss what this longer term context means for communities and heritage at our CHERISH study site. Thank you very much.